All right, here's some more on sequences. We're going to talk about explicit recursive formulas. All right, let's get back to the beginning here. So, example 1, if given the explicit formula, can you write the third, fifth, and seventh term of the sequence? Well, that's going to be as simple as when you're given the formula, if you want the third term of the sequence, then you would need to plug 3 in to that formula. So 5 times 3 minus 7 would give you the third term. So the third term here would be 8. The fifth term would be 5 times 5 minus 7, okay, 18. And the seventh term then would be 5 times 7 minus 7, and that would be 28. Same works for a geometric sequence. If I'm asking for the third, fifth, and seventh term, then it's as simple as plugging 3 into the explicit formula. Now remember here, order of operations, 2 to the third comes first. That's 8 times 3 is 24. The fifth term, plugging 5 in for n. Now again, you might have to use a calculator to do this. There's nothing wrong with that. All right, but you might know that 2 to the fifth in your head is 32, and then 32 times 3 is going to be 96. Now when you're getting into like 2 to the 7th power and doing those exponents and multiplying, then I'm thinking the calculator is probably best. All right, so if you're doing that, 2 to the 7th is 128 times 3 would be 384. Again, to get the third, fifth, and seventh term, you're simply plugging those numbers into the explicit formula that you have. Third term in here, negative 7 times 3 plus 83. So that's negative 21, and 83 is going to make 62. And then we'll have negative 7 times 5 plus 83. So negative 35 and 83 is going to make 48. That's your fifth term. Your seventh term would be negative 7 times 7 plus 83. So it doesn't matter what type of sequence we're talking about. If you have the explicit formula, you're going to be able to find any term in the sequence that you want. So the seventh term would be 34. What if we're given the recursive formula, right? The third, fifth, and seventh term of the sequence. This is a little bit different. Here, what I would tell you is a recursive formula. We're not going to do a lot with these, but what this tells you here is that the fourth term, a sub 4, is 9. So if the fourth term is 9, okay, so our fourth term is 9. I'm looking for my third term, so one before that, my fifth term, and my seventh term. So imagine it like a table. So if my sequence is generated by adding 6, 9 plus 6 gives me 15. That's my fifth term. 9 minus 6 plus 6 going forward minus 6 going backwards gives me 3. That's my third term. If I wanted my seventh term, I would have to add 6, which is like adding 12. That would give me 27 for my seventh term. So using a recursive formula is a little bit different than an explicit formula. Here in the recursive formula, it tells me that my second term is 14. So my second term is 14. I would like to know my third, my fifth, and my seventh. It is generated by multiplying by 2. So 14 times 2 is 28. That's my third term. If I want to get the fifth term, I'm going to have to times by 2 twice, which is the same as timesing by 4. That's 112. And my seventh term, same thing, times by 2 twice, okay, with 448. Again, to get this, I'm multiplying by 2. And you can fill this table in however you want. You can times by 2 again, times by 2 again. That's what this part of the recursive formula tells you. Okay, so here we need to remember that term numbers in sequences are always integer values. That means they're positive and they're whole numbers. So if I'm trying to determine whether a term is part of a sequence, so here is 42 part of this sequence. So 42 is a term of the sequence. That means it's like a y value. And we're trying to find the x or the n value. So if I plug 42 in, 42, is that going to equal 5n plus 2? That's the question I'm trying to answer. The only way to find out is to solve that equation for n. So if I minus 2 from both sides, so a little equation solving practice here, which some of us still need, and I would get n equals 8. Then I ask myself, is 8 a positive number? Yes. Is it a whole number? Yes. So that means 42 is the 8th term. Now, geometrics are a little bit different. In a geometric sequence, is 6,200 part of the sequence? If so, what term is it? So 6,200, is that going to equal 6 times 2 to the nth power? This is a little bit different. I still start the same way, though. I divide by 6. Okay, so when I do 6,200 divided by 6, I'm trying to then figure out is 100 or 1,033 and 1/3. Okay, is that going to equal 2 to the nth power? All right, and a lot of times this is guess and check. So I'm going to just pick a number. Let's say 2 to the 10th power. Okay, 2 to the 10th gives me 1,024. So that's a little bit lower than 1033. So then I want to find out what 2 to the 11th is. Because remember, term numbers must be positive and whole numbers. So I don't have to worry about any decimals in between. 2 to the 11th, well, guess what? That's 2,048. So do I ever hit 1033 and a third? No. So is this part of the sequence? No. Writing an explicit formula if you're given 2 terms of a sequence. So now I'm going to give you 2 terms of a sequence. You will need to first find the generator. Remember all the parts here, of finding an explicit formula. First, find the generator, find the initial value. Once you have those 2 pieces, you will be able to write the explicit formula for the arithmetic sequence. We probably won't do this for geometrics. So there's a couple ways to go about this. You have a 4th term here, and then you don't know anything else until the 12th term. The 4th term is 15, the 12th term is 55. So what we're trying to find out here is what is the difference between 55 and 15, and then how many steps did we have to take in between to make up that difference. So 55 minus 15 equals 40. All right, so this changed by 40. How many steps did we take, or how many terms happened in between? 8 terms. 12 minus 4 is 8. And then we divide those 2 answers, and that will tell us our generator. So 40 divided by 8 is 5. So my generator is 5, plus 5, because it's increasing. To find my initial value, I just need to go backwards. So I know the 4th term is 15, 3rd term, 2nd term, 1st term, 0 term is the one I want. So if I minus 5 each time going backwards, remember forwards is adding 5, which means backwards is minus. I'll have 10, 5, 0, and negative 5 for my initial value. Once you know the generator and the initial value, writing the explicit formula is very easy. So in this sequence, T of n, you can name it anything you want. I named it T for Tim. 5n minus 5. Generator, initial value. We went over that in the last video. So there's more on sequences.